I am joined by Rob Davies, who is the VP of Product Management from MicroStrategy. Rob's going to be talking us through an awesome session all about tech and cultural barriers to mass adopting of AI and ML-driven analytics. Like I said, Rob's left lots of time at the end for Q&A, so do be sure to submit them as you think of them, and we'll get to those at the end. So without further ado, over to you, Rob.
Thank you very much, Catherine, and thank you for having me today. I really appreciate it. Today, I want to talk about a subject that's very close to my heart. It's about how human beings and artificial intelligence and machine learning actually work together to make businesses better. So let me give you a little bit about my background first. I've been about 2.5 years at MicroStrategy, but before that, I was at SAP and Business Objects for 15 years and Tableau for 4 years as well. And what I really learned during those periods of time was people want the machine to help them make decisions in the enterprise. But honestly, people want to be able to trust the data as well and want to feel like they're really involved with how data is used in their business process. So when I think about what is necessary for mass adoption of analytics and mass adoption of artificial intelligence in the enterprise, I think about 3 things. The first thing is access. You have to have a way to get access to data to all the people in your organization. And that means people of all levels of data literacy. So whether or not someone is a practitioner of data science, or whether someone is a dashboard consumer, or whether someone is just someone who's out there in front of the customer every day, you have to find appropriate ways to give them access to data so that they can make their day-to-day job better with access to that information. The second thing you need to give people, and this is something we don't think about often enough, is a way for them to act on the data that they're given. How many times have I been with a customer and they say, oh, I have this great dashboard, or I have this great analytic, and it's telling me all kinds of important things, but I have no idea what to do next with that data. You have to give them a way to go into their base systems and say, oh, I got this dashboard today. It's telling me I should do this upsell for customer X, and I can click on a button to make that marketing campaign happen. You have to find ways to give people that ability to act on data. And finally, none of this works unless you have the underpinnings of the whole system, which is people need to trust the data. They need to trust the data they're making decisions on every day, but they also need to trust the data that the algorithms and the models are being made on in artificial intelligence, so that they trust those black boxes as they go forward and do their day-to-day work. So let's remember those 3 things as we go through this presentation and talk about the relationship between the data scientist and the average consumer in the organization. Everyone needs access. Everyone needs the ability to act on data, and everyone needs that comforting layer of trusting governed data that they can work on and that they can make decisions from. So the data scientist really needs trusted data to be successful. And if I talk about my background before I came into business intelligence, I spent years as a particle physics graduate student. And one of my first jobs was building artificial neural networks to search for the Higgs boson. And what I realized was every single time you make an artificial intelligence method, you need to be sure that the data you're building it on is the same as the data that everyone else in the organization is reporting on. So everyone in the experiment I was working on needed to have access to the same data that I built my method on. And we see that this is still true in business today. Data integrity is still the main reason why data science programs fail. How do I know that I'm building my algorithm, building my model on data that everyone else trusts in the organization? Plus, we have the challenge that data scientists are still spending the majority of their time on wrangling data, on building ETL methods, on getting the data they need into their tools to make decisions with. So to succeed, you have to have your data scientists to have access to repeatable data that, while updated for time, is still coming in via the same data dictionary, the same definitions, and allows them that same trust in the data. So platforms like MicroStrategy, for example, give you that through our semantic graph, making sure you have exactly the same data definitions as you continually update and continually train your model. And this allows you to do some special things, right? We know some of the challenges in data science today. Biases in models, the facts that when you bring certain elements of data in to train a model, you might be intrinsically introducing bias into that model. And what we found is when you have a very well-defined data dictionary, a very well-defined single version of the truth, that allows you to do trade-offs of accuracy versus bias, for example, that allows you to trade a little bit of accuracy to get less bias in your models. Let's talk about the second half of that, though. We know that data scientists need access to this trusted data to make believable models and to give those models to the rest of the organization. But more and more, we're seeing a breaking down of the barriers between business intelligence tools and data science tools as well. Data scientists, in fact, need to become storytellers. What good is it if your model only stays with you as a data scientist or with a small group of analysts, when it could be made into a full business process that allows people to act on that model and to make better decisions across the enterprise with that model? And here we have a couple of quotes about where we think the future of data science is going. Data scientists just aren't going to be the guys in the white coats anymore. They're going to be people who need to be able to analyze that huge amount of data available in the enterprise, but then be able to communicate the results of their analysis to the broader community. And as such, they need to have access to business intelligence tools that are well integrated with their data science tools to allow them to do that data storytelling. So let's kick this off with a little bit of a question about how your data scientists are deployed today. What percentage of the time of your data scientists is spent on data integration and wrangling before they get to any sort of real analysis or real model building? Is it less than 25% of their time? Is it between 25 and 50%? Or really are your data scientists spending most of their time wrangling data, trying to get the right data into the tools so they can build models to inform the rest of the enterprise? So let's take a couple minutes and have you answer this question. I think this is very interesting, right? Because we know data scientists are a highly paid, very valuable part of the organization. And if they're spending a large portion of their time really just trying to do the ETL tasks to start their initial analysis, that potentially is not a great use of time. So a couple more minutes answering that question, then we'll look at the results. All right, so this does underline pretty much what we've talked about, which is data scientists are spending a lot of their time wrangling the data, getting the ETL into the system, and really defining their own single version of the truth, when they could be benefiting from an enterprise-wide semantic graph that allows them to skip this step entirely and train their models and inform their models on the data that's being used by everyone else in the enterprise today. And what that brings us to really is that data science and business intelligence must integrate. And honestly, this is interesting to me with my background, having been a data scientist early in my career and now having spent 20 plus years in business intelligence. But there's really three things you need in a business intelligence platform to bring that value from data science to everyone in the enterprise to act on, and for everyone to build into their data process and their business process. The first thing is you need trusted data. And this is the old concept of garbage in, garbage out. If you're training your algorithms and training your methods with data that no one else trusts or data that's not certified across the enterprise, you can't expect that people in the enterprise and the practitioners in the enterprise will trust your results to make business process on and to build business process algorithms. The second thing that we need, and I'll get into this a little bit later, is an open architecture. Because we know data scientists have tools that work well for them today. We shouldn't be trying to recreate data science tools in the business intelligence platform, but rather figuring out ways to integrate those data science tools into a full spectrum business intelligence platform in a way that makes the data scientist a first-class citizen of the business intelligence community. And thirdly, and I think this is the part we really don't think about enough, is how do you then publicize and make actionable those data science algorithms to everyone in the enterprise, regardless of their level of data literacy? You want someone in front of a cashier's desk or someone on a shop floor or someone in a manufacturing line to be able to act on machine learning and artificial intelligence methods the same way as if they were a data scientist. And so what we've done at MicroStrategy, as an example, is to build an open platform that allows any user of business intelligence plus data scientists to contribute to that growing intelligence of the organization over time and to contribute to the way people use machine learning in practice. So when I think about what we're doing here, we're trying to make our semantic graph available to all types of business users, whether they be analysts using tools like MicroStrategy, Power BI, Tableau, or Click, business users using the Microsoft Office suite of products, or even developers making custom mobile and embedded applications out of the data that's in the single version of the truth with MicroStrategy. But more to the point of this talk is we've expanded that now to include the data scientists, the people using RStudio, the people using Jupyter, who now can use the same trusted data and governed data coming from the MicroStrategy semantic graph, and then publish the algorithms that they've created from that data back to the semantic graph, back to the MicroStrategy platform to be used in any of the intelligence applications created for analysts, for business users, and for developers. So this really closes the loop between what the data scientist is doing and makes them into a real contributor to the business process that everyone else in the enterprise is using through the tools that they already use today. So why is this important, right? Because you've seen other people try to make data science algorithms, simple regressions, tools like that within the business intelligence tools they use today. But what we've realized is data scientists have years of experience in mastering their craft in tools and in languages like R and Python. So we've decided that really the better way to bring the data scientist into the whole community is to let them use the tools that they love and the tools that they understand today to contribute to enriching the data that everyone else is using in the enterprise. And that goes beyond just programming languages like R and Python, but also goes into auto machine learning tools like DataRobot, SageMaker, that sort of thing, and integrating those into the platform as well. And the chart on the right-hand side just really supports what I'm saying. When you look at how many new projects data scientists are doing in what language, by far the majority is R and Python, and really thinking that we're going to change the way of working of the data scientist as we try to make them more involved in the entire group of business intelligence people is really misguided. We need to make sure that we're embracing those tools that they already use today. And the last thing is really, how do we use machine learning to augment end user workflows? And it's true, not everyone is going to become a data scientist, right? Not everyone is going to become even a business analyst. We need to make sure that people have tools that are appropriate for the level of data literacy that they have today. And that's where I want to introduce a concept called hyperintelligence. And really this concept is almost an old concept. And I'm going to date myself a little bit here, but when I talk about hyperintelligence, hyperintelligence is really the ability to build a 3.5 by 5 inch index card that is available in any tool that people already use today, in their email, on the web, in Salesforce, in Workday, anywhere where they might want to see some data based on something that they can hover over. And we've actually even gone beyond that in hyperintelligence today, where we're connecting all enterprise data from all sources through the MicroStrategy semantic graph in a hyperintelligence card where you can see everything that makes sense to see about that concept, be it a customer, be it an insurance claim, be it a high wealth client, be it a particular product that you're trying to offer in the banking industry, and then have your staff be able to make actions on that particular card right from where they are. Which means that, for example, as an insurance adjuster, I might be out in the field, be able to look in my email about the claim number for a particular claim that I'm looking at, hover over that claim in my email, see a hyperintelligence card that has every bit of information about that claim, the name of the claimant, the type of claim it is, the amount that's being claimed for, but also elements coming from artificial intelligence and machine learning, such as what is the risk of this being fraudulent and so forth, and be able to act immediately from the field on my iPad or iPhone to be able to say this claim is approved or denied as far as I'm concerned. So it speeds the time to value, it speeds the time for people in the field to be able to make actions and decisions from real data and real artificial intelligence and machine learning. So let's go to another survey question here. And this goes to my whole question about how do we bring more usage of artificial intelligence and machine learning to people across the enterprise. What percentage of your organization is able to leverage AI and machine learning models in the tools you use every day? And here I'm not talking about business analysts. I'm not talking about other data scientists. I'm talking about frontline workers, insurance adjusters, brokers, cashiers at the bank. What percentage of the people in your enterprise are able to leverage the models that your data scientists are creating? So let's take a couple minutes to answer that question and think critically about it. Is the methodology you have today able to bring the value of those models to more people and to people who are actually making day-to-day business decisions across the enterprise? So let's take a look at those results now. So again, this is similar to what I would have thought. Almost half of you are saying that fewer than 10% of your employees are able to leverage machine learning and artificial intelligence today. Some of you are making some progress, another 44% of people making it between 10 and 30%, which means you have some integration, I would imagine, with business process and also with business intelligence tools. But on that high end, which we really want to get to, is at least half of the organization using these models, or more than half of the organization using these models. The number's very low. So let's look at some use cases now and see maybe how we can bring those use cases out to where we are leveraging more machine learning, more artificial intelligence across the enterprise. So when we think about common use cases for artificial intelligence and ML in the enterprise, you have the common ones, right? You want to do ETL. So basically you have big data sources, you're going to use some of your artificial intelligence tools like R, like Python, like Databricks to load a cube or to load some data source. But that's sort of a first level problem in order to make a data source based on artificial intelligence. The next level is really exploratory data analysis. So how do you take data that's already in a data source that's accepted as a single version of the truth by the enterprise and leverage that in RStudio, in Python, in Jupyter, in order to build models that are then leverageable by the rest of the organization. And really the ultimate state is when you get to full machine learning integration, which means you have a two-way path between the data sources, the cubes that are being leveraged by the rest of the enterprise, and the artificial intelligence and machine learning tools that the data scientists are using. And when I say two-way path, it means they're using corporately governed, corporately trusted data to train their algorithms and to inform their algorithms, and then using that same data to push back to the cubes that are then being used for reporting and being used for business process in technologies like hyperintelligence across the enterprise. So let's look at a couple of use cases here. So these are anonymized use cases that we've seen in my company, but I'm sure several of them will resonate with you. So the first one is forecasting insurance claims, so predicting future amounts of claims so that you can get executive stakeholders on side to predict budgets and make sure that liquidity is appropriate and all the rest of the things you need to do. And the way that we've handled this at some of our customers is to acquire data on claims and all of the demographics around claims, location, type of claim, weather information, all of those things you need in order to find a 360 degree view of a claim, and to load those into a MicroStrategy queue, a MicroStrategy project. And then using RStudio or using Jupyter, you then create a model around those claims that shows what the forecast could be over time given various elements in that claim. And you then, when you've trained that, you create a hyperintelligence card to give access to people in the field and executives to make decisions from that claim. And finally, you deploy those dashboards, you deploy those hyperintelligence cards, so people see the results of that machine learning simply as any other data they would see that they can make decisions from without having to do any further work or become more of an expert on artificial intelligence. And the end state would be to have a claim card, such as this, for example, where you would see the claim amount, you would see the risk associated with that claim, and you could go back to an entire aggregation of the claim amount across different geographies and then adjust for different things like weather patterns or whatever you need to do to see what that eventual claim should be. But it would all be based on the same data science algorithms that your data scientists had created. I think what's really interesting in the data science space is two things. The first thing is data science is going to become more democratized, and that's going to be through methods that I've talked about before, through a true integration from traditional data science tools into business intelligence tools and into zero-click technologies like hyperintelligence, so people can make decisions leveraging those data science algorithms without ever knowing that they've actually done that. And the second thing is how quick model selection and deployment is going to be. It's not really going to be data scientists creating your average model anymore. Through technologies like data robots and AutoML, you're going to see more and more machine learning algorithms be created pseudo-automatically as data is fed into them. And just to give you an example of that, loan quality analytics here is an example where we've collaborated with Data Robot at MicroStrategy in order to look at how AI can be used to explain the causes for approvals and rejections to applicants. And so when we look at that, it's a similar process, right? You acquire data from all of the demographics around your loans, what the income of the family is, if I'm talking about mortgages now, what the demographics are, what their loan repayment is, what their credit history is. Then, instead of hooking up a traditional data science tool like RStudio or Jupyter, you hook up Data Robot to find those key drivers in the data and to really show what the key drivers are in an acceptance or a denial process. And then you're able then to deploy that out to everyone using a hypercard or using a dashboard so that a loan officer can easily say, oh, I see that the most important dimension in the approval of your loan was your credit rating, and I'd like to congratulate you on that. So it actually becomes something that's very good for customer satisfaction as well. So just to close, and we're very near the end here, I think if we think about the steps to success for bringing mass adoption of AI and ML in the enterprise, there's really 4 steps to that. And I've outlined the details for that in these 4 steps. The first one is really the basic one. Achieve trust in the data. If everyone, including your data scientists, are going out there and getting whatever data they want from the base data sources directly, there's no way for you to know that that data is actually the same model, is the same data definition, is the same data dictionary that everyone else in the enterprise is using. So you need to choose a platform with a strong semantic graph that will give everyone access to that same single version of the truth. The second one is enabling your data scientists. These guys and girls have trained for a long time on their tools that make them powerful interpreters of data and powerful predictors of the future. So you want, rather than to give them a new tool to use, to leverage that learning they already have in tools like R, in tools like Python, in languages like those, but also the IDEs like RStudio, and integrate those into a full 2-way conversation between trusted data to train the models and then being able to publish that AI-enriched data back out to the platform for everyone to use. And thirdly, and I think I've said this a couple of times now, but I'll reiterate it again, You have to figure out a way to give access to machine learning models to everyone in the enterprise, regardless of their level of data literacy. Don't assume everyone's going to become an analyst or everyone is going to become a data scientist. You have to find a way to make acting on the results of machine learning automatic. And you can do that through tools like zero-click analytics, like hyperintelligence, like these simple concepts of a card that just show up in every tool you're trying to use and augment them with data. And finally, allow non-technical people to make decisions using AI and ML. Figure out a way to link them back into the base systems where they need to make decisions, and do that through an easy-to-use augmenting technology like hyperintelligence, where people can see the results of an ML algorithm on what they're trying to do, and then click a link to approve an opportunity in Salesforce, or click a link to approve a hire in Workday, or click a link to approve a loan in your system of choice. But make sure that people are able to act on the data and really become integrated with the data in a way that makes them feel like data helps them do their day-to-day job. So that's really, in a nutshell, what I wanted to say. If you want to find out more, and you'll all get these slides afterward, you can experience hyperintelligence through a virtual design workshop, which myself or a member of my team can lead with you. And we also have a number of white papers that you can read on technologies like hyperintelligence, zero-click analytics, and particular hypercards and ways to deploy hyper and federated analytics for the financial industry. So I hope that's been useful for you today, and I think we can open it up to questions.
Brilliant, Rob. Thank you so much for that fantastic session. And thank you for the energy you've really brought to this. It's been fantastic. Thank you to everyone who has submitted a question through the Q&A module. Do continue to do that. We do have a bit of time here for questions. And just a reminder that only us in the back end can see those questions, so don't be nervous. No one's going to know it's you that's submitting them. So let's jump straight into one of these here. So someone's asked, aren't the models too difficult for the average user to understand? So I think they're asking about kind of, is it important to democratize data science? Yes, models are complex. Models require you to understand what data to bring in that are key drivers in a output or a result. Now, the key here is to hide that complexity or package that complexity for the end user. And so what you want to be able to do is, for example, a loan adjuster to go out in the field and to say, oh, I'm looking at this particular claim. This tells me there's an 80% chance of fraud on this. So you should look a little bit more deeply into what's happening. And to do that, I don't need to understand the model at all. I just need to trust the model. And so when people ask me about this understandability of models, I often say the real question isn't understandability. The real question is trust. How often have you gone out and that model has given you a result that helps your job? And how often hasn't it? And this gets into something I didn't get into at the talk, really, but if we measure the way people act on machine learning, so again, go back to the insurance adjuster example. If I'm out there in the field and I see, oh, 80% chance of fraud, but everything looks fine here to me, I'm approving that claim. Eventually, that data can make its way back into the machine learning algorithm as well. And we know something is wrong with the algorithm because 70% of the time, the person in the field decided against it. So again, instead of thinking about understandability, think about trust, and again, looping the human being back in. We're always going to be better at making decisions in the machine. What the machine can help us with is giving us an aggregate of data over large data sets that are impossible for our brains to figure out. Fantastic. And just kind of elaborating on that point, because I think it will be a question that kind of arises from that. Have you got any best practices for creating that trust through your enterprise, especially those who are perhaps less far forward in their journey to becoming data-driven and actually still rely quite heavily on their gut decisions? And then this seems like a giant launch forward from that. Kind of what top tips do you have for that? So one of the big things, and it comes back to something I said in the presentation, which is if you can integrate your analytics system and your data science system, it helps you convince people that future-looking results might be right. Because if you have in your analytics system
past-looking results. And you can say, oh, look, if we'd only applied this level of risk tolerance on claims in the last 6 months, then our payout would have been this much less, or our fraudulent payout would have been this much less. And then you can say, I based my algorithm on exactly those same assumptions with exactly the same data, and now we're looking out for the next 6 months. So if you guys in the field can all keep it to 60% risk or less, we will be fine. That helps with that level of trust. So again, people will believe the past, people won't believe the future unless you link the two together.
Absolutely. And I mean, you know, it's exactly what you said, isn't it, about the storytelling and having those user cases that are really strong to forward push that message. That's fantastic. Okay, let's dive into another one we have received in. Keep them coming, guys. So given the synergy between the modeling work performed by data scientists and analytics end users who want to be able to make business decisions with AI and ML, why have the tool sets for data science and business intelligence traditionally been different? Great question.
It's a great question. Having done both in my life, I strongly believe they should have been the same tool set from the beginning, but that's not the case. And it's quite simple why. You had database decision-making only really come to the forefront of business in the late 90s, early 2000s, right? And before that, we had a lot of scientists who were essentially doing data science, and they were building programming languages to do that. So you had, you know, for lack of a better word, and I can say this because I am one, but you had a bunch of geeks going out here and developing data science algorithms in tools like R and Python, and Fortran back when I was a young one. But and then out here you had all of the business people using business objects, using Tableau, using whatever tools they're using to get data. So the two tool sets never came together. And that's only because of how people were trained and what people use. But again, I think it's important to realize, as I said in the presentation, we shouldn't try to force people into a box they don't want to be in. Data scientists are already using these tools. They should continue to use these tools. And we should figure out how to leverage those more widely in the business intelligence platform through things like federated analytics and a single version of the truth.
Fantastic. We've had a couple of questions come in. I'm just going to merge them together because I think they're on the same path here. So they would like to know essentially how COVID-19 is going to impact the role of the data scientist. And it was mentioned in one of the questions that people are far more data hungry now. Is that going to impact the role? How do you see that?
Let me just say, I think data scientist jobs are safe, that's for sure. And I think especially in FSI, this is for a number of reasons. I see a lot of pressures on FSI at the moment in response to COVID, basically to respond to government regulations much more quickly. So we see in a number of countries, you know, I live in France, so we see this happen in France, but in the Nordics, we're seeing this, even in America and Canada, we're seeing this, where governments have instituted some very short timeline rules on financial institutions about how you're going to liberate capital, how are you going to do loans to keep businesses open. But at the same time, they've said, you better give me a weekly report on how you're complying with this and making sure the money's not going to the wrong place. And so I think data scientists are going to have to really react quickly to monitor and to model risk in these new loan environments. And the BI staff are going to have to move very rapidly to figure out how to report compliance on these things and understand how also it's affecting the bottom line of the bank or the insurance institution. Because, you know, as financial institutions take on more risk, their bottom line is becoming under more risk. And how do you actually model that in a way that you can see if complying with these new government regulations is putting your business at risk as well, right? So there's a lot of work to be done there, and it has to become agile. You can't take weeks or months to come up with an algorithm anymore. It has to be done in days, and the resulting measurement has to be done in days as well, so you can get that actual reporting out to the government authorities.
Absolutely. I think that's something across all industries which has happened, which is everything's happened so quick, and being quicker is the name of the game. And actually, it's really interesting you should mention agility, because one of the last questions we've had in is, how can an open business intelligence platform help make the use of AI and ML models more agile?
Yeah, and it's something I talked about, I think, in the last 5 minutes or so, but really, agility is all about, in data science anyway, is all about measuring, is data science having an effect on your business process? A positive effect, a negative effect? Are you measuring the right things? Are you predicting the right things? Are you getting help out to the business practitioners based on the models that you're making? And if you have a well-deployed business intelligence mechanism and tools like hyperintelligence, where everyone in the industry is saying, oh, I see this risk factor, I've made this decision. Oh, I see this loan capitalization, I've made this decision. Then all of that information gets captured in the platform. And all of that telemetry can be used in an agile fashion to train your models better and to make better models out of data science. So when I think about agility in data science, it's silly to think you're going to make one model and it's going to work forever. You have to be constantly monitoring, the effectiveness of those models and how the people in the business, the practitioners in the business, are using those models. And if your business intelligence platform can accomplish that, and then your data scientists can get access to that data quickly and modify and make their models better, that's what brings true agility to the data scientist.
Absolutely. And on that fantastic note, that is all we have time for today, Rob. Thank you so much for that session.
Thank you, Catherine. Appreciate the time.
Brilliant. And as you can see on the final slide there, we do have Rob's email address, and also on your screen, you should be able to connect with Rob on LinkedIn. So make sure you guys do that.